Hello, this is Gregory. Today we'll program a robot to self-aim at a pin or any other object, stop at a given direction, and then adjust that distance to precision. So it will be adjusting both distance and direction. So you can see there are two distance sensors on the front of the robot and a pin placed not exactly in front of the robot. So now let's run the program. You see the robot self-adjust direction, stops at a distance, and then finally adjusts both direction and distance for precision. So the robot responds to the error in direction. If the pin is exactly in front of the robot, the distance to the pin from both distance sensors is same. The error is 0. If you shift the pin, let's say to the left of the robot, then if the error is left distance minus right distance, it will be negative. And the response would be spin right wheels a bit faster and left wheels slower. So that would be our response. So now we need to connect response and error. There are two situations. If both sensors are on the pin, the difference in distance will be very small. And then the smaller the distance, the closer you're on target, and the response should be proportional to the error. However, if the error is large, one distance can be on the pin and another is just around the pin, it will be measuring distance to the wall. The error will be huge. And if we do a proportional response, the robot will overreact and probably will start spinning. For my experimentation is if the error is 2 or less, you can do proportional response. And if it's larger, you just do a flat response and adjust the wheel speed. Now let's look at the code. So when you start, you can do a forever loop and it will be always calculating your response because you will use response on multiple occasions. So first, as we talked about, set a variable direction error to the distance to the left sensors, it's port 7, and minus right sensor port 8. And if this difference is larger than 2, it means just do a flat response, 20. So you just divide error by its absolute value, it's just a sign. So it's 20 or minus 20 speed, depending on direction. And if the error is less than 2, then response should be proportional. And the coefficient for my experimentation is 7. But you can play around with that, depends on your robot. So now responses, you will always have this value and can use it in your program without doing this thing every time you need it. So a good approaching speed is 20, but of course you can change it. But the slower you approach, the more precision you will get. And do it until you reach the target zone. And the target zone is distance plus error to the distance minus error. So you enter the zone when you average distance say one sensor plus another sensor divided by 2 is less than distance plus precision. It means you entered this target zone and stop. When you're doing this, drive, and the drive block is just spin the left wheel and spin the right wheel. And velocity, that's speed corrected by response. If there is no error, those speeds are same. There is nothing to correct. If there is an error, the robot will turn to the left or to the right to correct the direction. And then it stops and waits for 0.5 seconds for inertia for the robot to settle down. So now the question is where you stopped. By inertia, you can just miss the zone and be too close. Or after some cycles, you can be too far. So now you analyze your position to the target. Set speed to 10. So now you just pretty much on the target, good direction. You just need to fine-tune the distance. And the speed is 10, is enough for that. So check the target. So if the average distance is larger than distance plus precision, you are too far from the zone and need to drive more and drive for 0.5 seconds. So this little program, it just let you drive for 0.5 seconds. Reset timer and drive until timer reaches 0.5 seconds. And do same adjustment of speeds by this response. And then stop. You don't have to print and do any comments. They don't affect the robot, but it's convenient for you to understand how it works. Then, if you're not too far, you go to the else part of the operator, and then it checks maybe you're too close. And if your average distance is less than distance minus precision, you're too close, and you need to drive back a little bit. Do same thing, and then drive back for 0.5 seconds. And back, there is a block which just spins left and right wheels in reverse. And stop. And for convenience, you can just print those values. For instance, when you run the robot, first it target zone was reached, then it was too close and done. So it just did one adjustment at the end. So console is a very convenient thing for troubleshooting and just understanding how the program works. So now what if it's not too close and not too far? It means you're on target. You're going to the second else. So you're done, stop and leave the loop. And the program is done. And you leave the loop by the command break. Because you don't want to do it forever, you want to do something else and run the next program. Thank you for watching.